Picture this. A driver loses a tenth of a second per lap, and the team can't find it in the engine, the downforce, or the setup. But then an engineer notices something on the telemetry. The tire pressure is half a bar too high. That single, invisible number just cost them a podium, maybe a championship. And here's the thing. It's not negligence. It's the margin between winning and losing in the sport's tiniest battleground. In Formula One, the difference between pole position and 10th place can be invisible to the naked eye. It lives in tire pressure, measured in tenths of a bar, managed across a 2°C window. Teams like Mercedes and Red Bull employ entire departments dedicated to pressure management, running thousands of telemetry calculations during a single race weekend. Because here's what most fans don't realize. As fuel burns off, as track temperature climbs, as a driver hits the apex with 5 Gs of lateral force, tire pressure shifts constantly, and living outside that narrow band destroys grip. A tenth of a bar too high, and you lose front-end feel and cornering speed. Too low, and the tire overheats, blistering on lap 15 and handing victory to your rival. This is where championships are genuinely decided. Not in the wind tunnel, not in qualifying trim, but in the unglamorous mathematics of thermal management during race day. So let's walk through what's actually happening inside that tire as a driver accelerates out of turn 1. When the Pirelli compound meets the track surface, friction generates heat instantly. We're talking 80 to 100 degrees Celsius within the first lap, sometimes faster on a hot street circuit like Monaco. That heat doesn't stay confined. It radiates into the air inside the tire, raising the pressure proportionally, which is why every team starts a race knowing their opening lap pressures will climb 3 to 5 bar before stabilizing. But here's where the physics tightens. The driver is also pushing 1.5 to 2 tons of car through high-speed corners, loading the tires with lateral forces, 4 Gs, 5 Gs, sometimes more, and that deformation, that flexing of the rubber, generates its own friction heat. Meanwhile, fuel is burning away, reducing car weight by 1 to 1.5 kilograms per lap, which lightens the vertical load on each tire, which mathematically lowers the operating pressure needed to maintain grip. And the track itself is heating up. By lap 20, an asphalt surface in July can be 15 to 20 degrees hotter than at the start. So the air under the tire is absorbing ambient heat from below while generating its own from within. That's 3 independent variables: driver inputs, fuel consumption, track temperature, all pushing and pulling tire pressure in different directions across a single race stint. Miss the window by just half a bar too high, and the tire is overinflated. It's riding on a smaller contact patch. So cornering grip evaporates and the driver feels vagueness, understeer, that disconnect that costs a tenth per corner. Half a bar too low, and the sidewall flexes excessively. The tire generates surplus heat, and by lap 15 you see blistering, small bubbles of separated rubber, which signals imminent failure and forces a second stop your rival didn't need. So when do teams see this window collapse into real consequences? Spain 2016 gives us a perfect case study. Mercedes had dominated qualifying, Hamilton on pole, but Rosberg's setup favored tire warm-up over peak operating range. A calculated gamble for the race itself. By lap 18, as track temperatures climbed and fuel loads dropped, Rosberg's tire pressures had drifted 0.8 bar above Mercedes' target window on the rear axle. The understeer was instant and visible. His pace dropped nearly half a second per lap relative to Hamilton, and strategically, Mercedes had no answer. They couldn't cool the tires enough without pitting again. That pressure miscalculation, born from an aggressive setup philosophy, cost Rosberg a win he should have fought for, and in a tight championship, that's 3 points you never get back. Now jump forward to 2021 Abu Dhabi finale, and this time the window worked in reverse. Late in the race, Max's Red Bull was running cooler pressures than Lewis's Mercedes, a setup choice that gave him superior tire management as the circuit cooled into evening. When the safety car bunched the field with 2 laps remaining, Max's tyres were in a sweeter window, warmer, more responsive, while Lewis's had fallen into that zone where contact patch had shrunk and response dulled. Max made the move stick partly because his tyre pressure profile, built over 50-plus laps of calibration, meant his front end had fresher bite when the restart came. These weren't freak results or luck. They were the mathematics of pressure windows playing out in real time, and teams that read that window won. Those who didn't. What if Rosberg had run just half a bar higher from lap 20 onwards, staying within the optimal window instead of chasing that aggressive edge? His tyres wouldn't have overheated into that unpredictable plateau. Instead, he'd have carried consistent grip through the high-speed corners where Lewis was gaining time. One different call in the garage, one number changed on the telemetry screen, and the championship narrative of that entire season shifts. Because pressure windows aren't marginal, they're foundational. So here's what we've learned. Tyre pressure isn't a detail, it's the invisible hand steering a season. First, the window is narrow and unforgiving. Just half a bar either way costs you tenths, and in F1, tenths are championships. Second, that window moves constantly. Fuel load changes it, track temperature changes it, and the wear of 50 laps reshapes it, which is why the best teams monitor every lap with religious obsession. And third, the driver who understands their pressure curve, who can feel it underneath them, and trust their engineer's calls, owns the advantage when it matters most. Now, we want to hear from you. Which corner of the sport should we dissect next? Brake balance sensitivity, fuel trim strategy, or DRS optimization? Drop your vote in the comments below, and please subscribe so you don't miss the next deep dive into the mechanics of winning.